Let's look at the properties of determinant. The first property, if the elements of one row or one column of a determinant are 0, then the value of the determinant is 0. So here, for example, we have determinant of 1, 2, 0, 0. We can see here that the element in the second row are zeros. So when we find the determinant, we have 0 minus 0, which is equal to 0. Another example, we have the second column, the elements are 0. So when we find the determinant is also 0. The second property is if two rows or two columns of a determinant are interchanged, then the value of the determinant is multiplied by -1. So let's say here we have determinant of 1, 2, 3, 4, which is equal to 2. If we interchange the column, so that means the first column will become the second column, and the second column will become the first column. So we can see that determinant is equal to 2, which is equal to negative of the original determinant. When interchange the row, it is also the same. You can see that the determinant is 2, which is equal to -1 of the determinant of the original matrix. For the third properties, the determinant of a matrix A and its transpose are equal. So that means the determinant of matrix A is equal to the determinant of matrix A transpose. Here we can see the example. The fourth, if the elements of one row or one column of a determinant are multiplied by k, then the value of the resulting determinant is k times the given determinant. So here, in the second row, we can see that the second row is 4 multiplied by -1, 1. The fifth property, if two rows or two columns of matrix are equal, then it has 0 determinant. So here we can see that the first row and the third row, the elements are equal, 1, 2, 3, 1, 2, 3. So when we find the determinant is 0. For the sixth property, if one row or one column of a determinant is multiple of another row or column, then the value of the determinant is 0. This is actually the same as the properties in number 5. Because in number 5, it is actually multiple of 1. 1, 2, 3 multiplied by 1 is 1, 2, 3. So in this example, we have 1, 2, 3 in the first row. In the third row, 3, 9, 6. 3, 6, 9, which is the first row multiplied by 3. So 3 times 1 we get 3, 2 times 3 we get 6, 3 times 3 we get 9. So when we find the determinant is also 0. For the seventh property, if we add or subtract a multiple of one row or column to another, then the value of determinant is unchanged. Here we have determinant of 3, 2, 0, 1. We add 2 times row 1 to row 2. So that means row 2 will be changed by adding 2 times row 1, which is equal to 3, 2, 6, 5. When we find the determinant is 3, which is equal to this determinant. Okay, for the eighth properties, the determinant of a lower triangular matrix, an upper triangular matrix, or a diagonal matrix is the product of the element on the leading diagonal. So for example here, this is an upper triangular matrix. When we find the determinant is 1 times 5 times 3, which is equal to 15. So this is a diagonal matrix. When we find the determinant, it is actually equal to 2 times 4 times 3. That is the product of the elements in the leading diagonal. And the last properties, the determinant of a product of two matrices A and B is equal to the product of either of their determinant A and B. So this we have seen in the previous example. Okay, let's look at example 18. Use the properties of determinant to find the value of x. So we must be alert with the changes occurs from the left side to the right side. So here we can see that the element in the first row are equal to the element in the first column. The element in the second column, in the second row, are equal to the element in the second column on the right side. So the element in the third row must be equal to the element in the third column here. So that means here, matrix A is equal to the determinant of the transpose of matrix A. That's why we can see that x is equal to 2. For the second question, we have determinant of 1, 0, 2, negative 2, 1, negative 1, 1, 3, 3 equal to the determinant of 1, negative 2, 2, negative 2, 5, negative 1, and 1, x3. So here we can see that the element in the first column are equal and the element in the third columns are also equal. So what is the difference here is the elements in the second column. So we must think how to change from 0 to negative 2, from 1 to 5, and from 3 to x. To get negative 2 here, it is actually 0 here, 0 minus 2 times 1, which is equal to negative 2. To get 5, it is equal to 1 minus 2 times negative 2, which is equal to 5. Therefore, x should be 3 minus 2 times 1, which is equal to 1. Therefore, x equal to 1. For the third example here, we can see that the element in the second row on both sides of the equation are the same, but the element in the first row and the third row are different. So to get 6 here, by using the element in the first column on the left side, it is 4 plus 2, and the number 3 here is 1 plus 2. That means to get the element on the third row on the right side, it is row 3 plus row 1. Row 3 plus row 1. So that means x is equal to 2 plus negative 1, which is equal to 1. We can also find x by using the first row. So let's see how to get the right side from the left side here. So to get 4 here, to get negative 4 here, it is negative 2. It is negative 2 minus 2. To get 4 here, it is 3 minus negative 1, which means row 2 minus row 1. This is row 2 minus row 1. So that means negative x is equal to row 2, that is 1, minus 2. Therefore, we have x equal to 1. For the last example, we have a determinant of an upper triangular matrix equal to 6. So by using the property to get the determinant of upper triangular matrix, it is the multiplication of the elements of the leading diagonal. So we have 2 times x times 1 equal to 6. Therefore, x is equal to 3.